Hello friends, I welcome you in lecture number 4 on complex integration. In this lecture also we will discuss one more example on evaluation of contour integrals. So we start with this example. Evaluate integral x square minus I y square along the curve C with respect to z, where this curve C is given by this parabola y equal to 2x square from 1 to 2 to 8. So here we have to integrate along the parabola, and our function is already given in terms of x and y. Here f of z is x square minus I times y square, and we have to integrate along this parabola y equal to 2x square from this point 1 to 2 to 8. We are familiar with the shape of this parabola. Suppose we consider this much distance as 2, then here also suppose this is 2, so we will have 2 plus 2 4, and here 6, and here we have approximately 8. Same thing here, 2 4 and 6 and 8. One point is 1 comma 2, so 1 is somewhere here, that is this point is 1 comma 2. Another point is 2 comma 8, that is 2, and here somewhere this is the point 2 comma 8. And we know that shape of this type of parabola is like this. It is parabola passing through origin in this shape. So we can roughly sketch the part of the parabola between these 2 points. Our parabola will go in this direction, and it will pass through origin, and it will go symmetrically in this direction. But we are not going to integrate along the whole parabola. We want to integrate between these 2 points. One point is 1 comma 2, another point is 2 comma 8. So this part of the parabola is the curve C, along which we want to integrate this function x square minus I y square. So you need not sketch the curve given in the problem, but this is just for understanding that we are integrating along this part of the parabola between the points 1 2 and 2 8. Now first we try to convert our function in terms of only one variable. Here our curve is given by y equal to 2x square, so we can replace y by 2x square in the given function. So f of z can be rewritten as x square minus I. If I replace y by 2x square, here I have square of y, so this I can rewrite as x square minus square of 2 is 4, I is there, and square of x square is x raised to 4. So our function is converted in terms of variable x. We will consider x as the parameter or only one variable, and then we will integrate with respect to x. Then we have to write our curve. Given curve is parabola. Given that curve C is y equal to 2x square, and it is between these 2 points, and we are going to convert our curve in terms of x variable. So here at this point value of x is 1, so lower limit for x is 1, and at this point value of x is 2, so we will keep x between 1 and 2. And therefore if we take any point z on this curve, then we know that z is x plus iy, and we can replace y by 2 times x square. Okay, we are using y equal to 2x square. Therefore we can rewrite z as x plus 2i x square. So we have written the equation of given curve in the form of x only, and x is in between 1 and 2. Then we differentiate z with respect to x. Now z is function of x only, so we can find out ordinary derivative of z with respect to x. Derivative of x is 1 and derivative of x square is 2x, and there is one more 2 here, so this is going to be 4i times x. Therefore dz will be replaced by 1 plus 4ix and multiplied with dx. Therefore we have converted dz in the form of variable x only. F of z is also converted in the form of x only, and x is from 1 to x equal to 2. So now we can convert this integral in terms of only one variable x. So in the next step we use all these things and we try to convert our integral in the form of variable x only. X square minus iy square dz, this is equal to x square minus iy square, that is our function f of z, and that we have written as x square minus 4i x raised to 4. So x square minus 4i x raised to 4, this is f of z, and dz is 1 plus 4ix times dx, and x is from x equal to 1 to x equal to 2. Now before integrating we can multiply these two using the definition of multiplication of two complex numbers. We know that if we have two complex numbers x1 plus iy1, x2 plus iy2, then this is equal to x1 into x2, that is real part into real part minus imaginary part into imaginary part, plus I times real into imaginary part, that is x1 into y2, plus imaginary part of first into real part of second. So using this definition we find out this product, and that we write in the bracket. So here real part is x square, here real part is 1, x square into 1 is x square. Here imaginary part is minus 4x raised to 4, here imaginary part is 4x, and we have minus sign from the formula, and there will be one minus sign from this imaginary part, so that is going to be plus, and 4x raised to 4 multiplied with 4x will give us 4 into 4 16, and x raised to 4 times x, that is x raised to 5. This is the real part of the product which we are writing, plus I times, now we consider real part of first, that is x square, and imaginary part of second, which is 4x. So that will be x square into 4x, which is 4x cube. Then imaginary part of first, which is minus 4x raised to 4, and multiplied with real part of second, which is 1. So this is going to be minus 4x raised to 4. Again we check real part of first, that is x square, multiplied with imaginary part of second, which is 4x. So x square into 4x is 4x cube. Then imaginary part of first, which is minus 4x raised to 4, multiplied with real part of second, which is 1. So this is correct, and here integral is with respect to x. So we have to be careful. If there is any single mistake, then we may get wrong answer. Now we use this property that whenever we have this type of integral u plus iv, integral with respect to some variable, then this we can rewrite as integral of u with respect to x plus I times integral of v with respect to x. So using this property we split this into two integrals with respect to x. This is u and this is v. So integral of u plus iv is equal to integral of u plus I times integral of v. So we are writing integral from 1 to 2 x square plus 16x raised to 5 integral with respect to x plus I times integral from 1 to 2 integral of 4 into x cube minus 4 into x raised to 4 integral with respect to x. So in this way we will first simplify given function and we are going to convert all these things in terms of variable x, because our curve is y equal to 2x square, so we can easily replace y in terms of x. So using this y equal to 2x square, we are able to convert this complex line integral in terms of real integrals, these two real integrals. Now this is easy to evaluate using the formulas of real integrals. Integral of x square is x cube divided by 3, integral of x raised to 5 is 16x raised to 6 divided by 6, and limits of x are from 1 to 2 plus I times, here we will have 4 into x raised to 4 divided by 4, or we can get 4 cancel directly, and here we have minus 4, integral of x raised to 4 is x raised to 5 divided by 5, and then we will put limits of x as 1 and 2. First we find out value of this. First we put x equal to 2 and then minus x equal to 1. So if I take x equal to 2 here, I will have 8 by 3 plus if I can get 2 cancel here, I have 3 into 2 6 and 8 into 3, and this is going to be 2 raised to 6, that is going to be 64, and divided by 3. This is for x equal to 2, minus for x equal to 1 we have 1 by 3 plus 8 by 3. This is for the first part, and plus I times, here we write for the second part, this will get cancelled. If we take x equal to 2, we have 2 raised to 4, that is 16, minus if I take x equal to 2, here I will have 2 raised to 5, that is 32, and it is multiplied with 4. So 4 into 32 divided by 5, minus when I take x equal to 1, here I have 1 and here I have minus 4 by 5. Then we can simplify this. Here I have 8 by 3 plus, if I consider 64 into 8, and that is going to be 512. 8 times 64 will give me 512 divided by 3. Here I split this bracket and I will have minus 1 by 3 minus 8 by 3 plus I times, here also I can simplify this, 16 minus 32 into 4, that is going to be 128 divided by 5, and here minus 1 plus 4 by 5, and then I can combine these two, or I can see that these two will get cancelled, and here I have 512 by 3 minus 1 by 3, that will give me 511 by 3 plus, here we can write one more step, 16 minus 1, that is 15, and minus 128 by 5 plus 4 by 5, that will give me minus 124 divided by 5, and then I will have 511 by 3, and here I will have 75 minus 124 divided by 5, and this I will get as minus 75 minus 124 will give me 49. So this is the answer. 511 by 3 minus 49 by 5 times I. This is integral of x square minus I y square with respect to z, where c is the parabola y equal to 2x square from 1 2 to 2 8. So you can see up to this point we have converted all the given things f of z and dz in terms of x, and once we convert them in terms of x, then we have simple calculations here. We are using the concept of evaluation of real integrals. We are just using this formula that integral of x raised to n is x raised to n plus 1 divided by n plus 1. But we have to be careful while doing all these calculations. So this is very nice example. They can ask you this type of problems in the examination. But what is the main idea is we are evaluating complex line integrals or contour integrals, and what we are doing, we are converting our variable z from two variables to only one variable, either in terms of x or in terms of y, or we are using parameter t, and after that we are converting dz in terms of either dx or dy or dt. Similarly, we are converting f of z either in terms of fx or fy or f of t, and we are able to convert our complex integral in terms of real integral, and that we can evaluate easily. So this is all about this session. We will continue with this type of problems in upcoming lectures. Thanks for watching.